Hi, welcome back to my YouTube channel, Just for Math. It's quite a long time. All right, so I got this request from one of my subscribers, followers, who wants me to solve this problem for their kids. The question is the instruction says factorize completely, and we have the first question, which is given as h squared minus k squared, right? Minus p into brackets h plus k. Okay, to factorize this means to express represent the expression as a product of its factors. Now, h squared minus k squared is a difference of two squares expression that can be written as can be written as h minus k times h plus k, right? And we have minus p into brackets h plus k. So this is by the property of difference of two squares. Difference of two squares. So whenever you see a squared minus b squared, this can always be expressed as a minus b times a plus b. So that is a concept that was used to expand h squared minus k squared. The next step would be to factorize, of course. But you look through the two terms of this expression, that is this term and this term. You notice that h plus k is common to both terms. So I can factor that out to have h plus k into brackets. Now when you factor this out, this is gone. I'm left with h minus k, right? Then minus, so let me open a square bracket, minus, this is out also, so I'm left with p. All right, so with this we have been able to successfully factorize the given expression completely. Okay, and of course you can leave the answer this way. So the factorized form is h plus k into bracket h minus k minus p. Of course, if you want to open the bracket, the curved bracket in that square bracket, so that you have this as h plus k, yep, into bracket h minus k minus p, and that is just fine. So this is the complete factorization of the given expression. I hope this is clear enough. Now let's look at the second question. That is the expression given as x plus y plus x squared minus y squared. Here for number 2, let's also apply the idea of difference of two squares. I can decide to write this expression as x plus y in a bracket, plus I also put this in another bracket, x squared minus y squared. All right, now since that can be applied in that way or that order, this will then be given as x plus y plus, I can have this bracket opened, a square bracket, so that we have here as x minus y by applying difference of two squares times x plus y. All right, and this makes sense, right? So when you look at the expression again, there are two different terms. If I so wish, I can take out this square bracket. Doesn't change anything, right? Doesn't change anything. Now looking at these two expressions that is being bounded by the addition, this plus sign here, you will find out that x plus y is common to both sides of the expression. So I can factor that out, x plus y. So here I have 1. Of course, x plus y divided by x plus y is 1 plus. All right, so x plus y is out, so we're left with x minus y. Can you see that? X minus y. And here's a factorized form of the given expression, x plus y plus x squared minus y squared. That gives the answer to the second question. Okay, let's look at the third question, the solution to the third question. Here we have 9x squared y minus 25 yz squared. All right, Okay, in this case, we apply this same theory or concept of difference of two squares by, first of all, let's factorize y. Y is common to both sides. Before I apply the concept of difference of two squares, I would like to factorize y, or factor out y. So y is going to be, the expression is going to be y into bracket 9x squared minus 25z squared. All right. With this, we but you might not be able to see this clearly, that you can apply difference of two squares until we are able to represent 3 or 9 as some form of square. So that is going to be 9. 9 can be represented as 3 raised to power 2 minus, and 25 can be written as 5 raised to power 2 z squared. Okay, which can further be simplified as 9 into bracket 3x all squared. Can you see that? Minus 5z all squared. All right, so this is awesome. Let's use square bracket here for distinct representation and clarity. All right, so here, as you can see, we are now qualified to apply difference of two squares in the terms in the bracket, the square bracket. So this becomes 3x minus 5z times 3x plus 5z. Okay, so far so good. We have the complete factorization of the given expansion above as y into bracket 3x minus 5z times 3x plus 5z. So here is a factorized form of the given expression. I hope this is clear. And the fourth and the last question is given as 4x squared minus y squared. And to factorize this completely, we also represent it in form of our difference of two squares, so that this can be written as 2x all squared minus y squared. And having represented the expression in this form, so we then apply the idea of difference of two squares, which goes by 2x minus y times 2x minus y. Great. And that's it. So you can see how these expressions were easily represented or completely factorized using the idea of difference of two squares. So it's a very powerful idea under algebra. Thank you very much for following me. Yeah, my follower, I don't know your name. I just got your message via WhatsApp. Thank you for following me. Thank you for supporting me, yeah, all this while. And if you have any other questions concerning the solutions, please feel free to reach out to me. All right, send me word to your kids, and I wish them all the best. All right, so if you have my followers on YouTube or Facebook, please keep following and share my videos if you find them resourceful. All right, bye bye. See you in the next one. Bye bye.